In this video we're going to look at how to simplify surds. So surds are useful when we are dealing with roots of numbers which are not going to give us a rational answer. So we can't express it as a fraction or a recurring decimal, so we're going to just leave it as a root. But we can write them more simply often. So root 50, we actually can write this in a more simple way. So how am I going to go about this? Well, I'm going to consider square numbers that are factors of 50. And I know that 25 is both a square number and a factor of 50. So I'm going to use that to rewrite 50 as the square root of 25 multiplied by 2. And that's going to be useful because I can split this into two separate roots multiplied together. So root 25 multiplied by root 2. And the root 25 bit, I know, is the same as 5. Now the root 2 bit won't simplify any further, so I just leave the root 2 there. So root 50 can be rewritten as 5 root 2. Question 2 then. I've got two different roots added together, and if I'm going to be able to add these together, then I need to simplify them, and hopefully I will find they are roots of the same number. So root 20 can be written as root 4 multiplied by 5, and root 45 can be written as root 9 times by 5. So I can rewrite that as root 4 multiplied by root 5 added to root 9 multiplied by root 5. Root 4 is 2, so that's 2 root 5, and root 9 is 3, so that becomes 3 root 5. And when I add these two terms together, 2 root 5 added to 3 more root 5s gives me a total of 5 root 5. This third example, I'm going to go through a very similar process again. So this first term, well, that's already as simplified as it's going to be because there are no square numbers that go into 6 other than 1, and that will leave me with the same term anyway. So that's going to remain the same for now. Now root 24, well I know 4 goes in, so I'm going to write that as 3 lots of root 4 times by 6. And something that can often be useful here is once you've identified that we've got a root 6 here, if it's going to simplify, then we're probably looking for root 6's elsewhere as well. So there we go, I've got a 6 there. And here I can rewrite 54 as root 9 times by 6. So now I'm going to simplify these. So that's 3 root 4 times root 6, subtract root 9 times root 6. So root 4 is 2, so that's 3 lots of 2 now, so that's 6 root 6. And root 9 is 3, so that's minus 3 root 6. So 2 root 6 add 6 root 6 is 8 root 6. Minus 3 root 6 will give me a total of 5 root 6.